Good day and welcome to my presentation. My name is Lukas Haag, I'm the Head of Engineering at Suntrace, and I'm very pleased to share some thoughts on best practice implementation of renewable projects for mines in Africa based on our experience as an independent consultant and renewable energy expert. The way ahead is pretty clear, and the decarbonization strategies were announced by mining operators. And now the big question is how to deliver to the ambitious decarbonization targets. And the first step is really break down the targets to the asset level and start with the quick wins. And the power supply offers by far the largest carbon footprint, and renewable energies present the lowest hanging fruit to really start decarbonizing your mining operations. It also offers very attractive business cases, in particular for off-grid mines, but also for grid-connected systems, where, however, it is a case-by-case decision. The main value drivers for renewable energies are for sure the reduced cost we see in the market and the overall competitiveness of renewable energies, and of course the option to reduce the carbon emissions, but also to hedge your energy cost for future operations. Considering the current volatility in fuel prices, and also increase profitability of the mine, and in some cases even extend the life of mine due to lower electricity cost, and maybe pursue options to explore lower grade resources. It's also clear that decarbonization is a long way, and it's a stage-wise approach. The way to net zero will be a long journey, and I say let's hit the road. So what would be the first step when looking at a particular project, a certain mine? It is really about set the project frame and get all the information you need to get a project approved. And it all starts with assessing the available land and the renewable energy resource, whether it be solar, whether it be wind. Identify the concept and the technology you need, which could be including a battery energy storage. It could be off-grid, it could be grid-connected. And also assess the options for integration of renewable energy into, for instance, an existing power operation. You also need to assess the project specifics, and in some of our projects we've been looking into the soiling, for instance, which can be a big concern depending on the environmental conditions. But we also had interesting opportunities to investigate new options for renewable power, such as a floating PV installation to be considered in a tailings pond. This obviously is a solution for boundary conditions where no land is available. During this initial phase, we also analyze the project economics and look into plant performance and cost, trying to get all the information together that is needed for the go or no-go decision. Once the concept is clear and the project is approved, the next phase is really all about confirming that the project is meeting operations requirements. So in this phase, it's about finding all the bits and pieces, doing all the homework that is necessary to define the interfaces, define the requirements for seamless integration of the renewable energy project into the existing infrastructure and also the continuing operation of the mine. Remember, it's a mine that is existing and in operation. We want to have zero downtime, so it's very important to be precise on this. In this phase, our engineers would go to site and review in detail the site features, analyze the geotechnical information, and make sure it's all prepared for the implementation phase. We would also verify the grid connection and have a more deep dive into genset requirements and control and integration requirements. So it's important to understand the existing thermal plant conditions and how it is operated. So talking to operators, understanding their needs to find a tailor-made solution is really crucial. In this case, we consider the ramp rates, for instance, that are to be considered of the engines. What is the time to start up an engine? What are the characteristics of the main consumers, such as the ball or the signal? How do you manage inrush currents during a startup of these consumers when there is a high penetration of renewables? These are all the questions that need to be asked in this phase. And this is also the phase where a consultant like Suntrace really adds value, because we have done it before. We know exactly what needs to be asked to find all the information needed. We would also run a detailed grid impact assessment and analyze the different layers of security to prevent load shedding at all cost. We can also narrow down the cost range and estimates and confirm economics and support in deciding whether the project shall be implemented based on EPC, IPP, or eventually leasing concept, and manage risk for the overall implementation. So this phase is really about being clear about your solution and finding the right approach before approaching the market. Then in this phase, I would like to point out one aspect that is really important, and that is related to the plant concept and the sizing itself. There is different software available in the market. However, commercial tools usually have some limitations when it comes to flexibility. And Suntrace has decided to develop its own in-house simulation software called AHEAD to overcome these limitations and really model and simulate tailor-made solutions for our clients. So this software offers modeling of grid-connected or off-grid systems, whether it be combined with, for instance, solar, battery, or wind power, and also consider gensets or turbines, as the case may be. We are also able to model in 1 minute time resolution, which gives you a good and a realistic simulation on, for instance, the smoothing of fluctuations and the utilization of the battery system. The tool also includes a inbuilt financial model, which is cash flow based, and an optimization engine that allows you to find the optimal plant configuration based on a techno and economic assessment approach. I would like to take the opportunity and show some of the key features this tool has to offer. It's certainly about the flexibility to accommodate all the project-specific boundary conditions, and also to reflect customized operating strategies and integrate the actual limitations of the existing thermal plants. Now, let's have a look at one of the result graphs we see here on the right. We see there's a fairly constant load over the day, and we also see that there's some wind power penetrating over the day, in addition to some solar power, which is highlighted in yellow. And as the share of renewable energy increases, the engines are ramped down till there is a point where some excess electricity from renewables is available, which can be used to charge the battery and then later discharge the battery to, on the one hand, smooth the solar or wind power fluctuations, and also to shift some of the load towards evening hours, while always keep engines within their operating limitations. And also consider the spinning reserve requirements and redundancy requirements of the overall grid. Now, this whole exercise is repeated many times in order to find the optimal plant configuration and the optimal sizing for your project. All right, so why do we do all this? It's not about creating lots of papers, it's really to be prepared for the next step. And the next step is the implementation and selection of the right contractor. So be specific about your requirements and define the quality and performance criteria for your project. Also, tender based on functional specifications derived from the previous assessments, and run a competitive procurement process to really secure market price for your project. The detailed assessment helps to overcome all the problems you might face during the implementation and the negotiation phase. So at the end, it will save time and cost. Okay, let's have a look at some of the best practice examples. And I would like to show one of our references that is related to the Tassias Solar project, very exciting project from Kinross at the Tassias mine in Mauritania. It's a solar and battery hybrid plant concept combined with existing HFO generators. Feasibility was conducted last year, and the project is currently under the EPC selection process, which is ongoing. Suntrace is acting as the owner's engineer to the Kinross project team and really enhance the project team to find all the bits and pieces required for the selection and implementation. We started up with developing the concept during the scoping study phase and provide basis for board decision. We also firmed up our performance estimates with a solar measurement station and conducted soiling analysis during the site selection process. The detailed assessment helped to determine the optimized plant sizing and define the requirements for the seamless integration with the existing system, based on functional and technical specifications which form part of the EPC contract. And as I mentioned, the selection process is currently ongoing, and it's an EPC selection for supplying the solar and the battery system at once. Another exciting reference for Suntrace I would like to share is, of course, the Vikula Solar project, which is in operation since July last year. And this project is really a landmark project. It's the largest PV battery hybrid off-grid system currently in operation. It consists of 36 megawatt peak solar power and a tracked system, and 17.3 and 15 megawatt hours. So it's 17 megawatt and 15 megawatt hours battery system. It saves up to 30 million liters HFO annually. And the concept allows to switch off half the generator capacity during the day and ramp down the remaining ones to allow up to 75% of the power to come from solar during a clear sky day. The operational experience is very good, and the project continues to outperform expectations. It also offers operational benefits due to the battery that are also recognized in the system and really help to improve the grid stabilization. Our role in this, Suntrace together with BayWa r.e., have developed the concept and then were selected by B2Gold as the owner's engineering and procurement contractor, including supervision and support during construction and commissioning of the project. Our work in this project was also recognized by AFCIA in 2020 as the Advisor of the Year. And Suntrace, as an independent consultant for renewable energies, has a strong focus on the African continent with several projects all around. We really provide an independent and client-oriented approach and provide the experience for the renewable energy projects, and we team up with your project team to help implementing the project. Key takeaways for this presentation are that renewable energy is the lowest hanging fruit to reduce carbon emissions, and it's really the first step to get going on this journey. Set the project frame and be clear about your solution is very important before approaching the market. Specify your requirements and run a competitive bidding process to secure a market price. A consultant like Suntrace can really support you during this journey, so please seek independent expert support as needed to team up your project teams. Thank you very much, and please also feel free to stop by at our virtual booth and get in touch with me or my colleagues Martin Schlecht or Ralf Jüngerglöd, who are also around at this conference. Thank you very much, and I'm looking forward to your questions.